Hi there, I'm Mr. Roche, and welcome to Mr. Roche's Flip Class Math 10 No Frills, No Thrills, Low Budget, Low Tech videos. Today we're going to be doing Polynomials Part 4, which I just simply call Other Polynomial Products. Before we start, again I have Wilson with me, still happy, still smiling, because he's doing more math. I'm going to sit him here. He also helps me with the camera when I need an extra set of hands, kind of. Anyway, the first thing we're going to do is talk about binomials times trinomials and trinomials times trinomials. Again, it's just a product of two things. Again, we could ideally use algebra tiles, but it gets really difficult using dimension as a trinomial because it just doesn't work with the binomial with the algebra tiles. So I'll just be demonstrating using the whiteboards. Second, we're going to be doing cubing binomials, and then we'll be doing multiplying/squaring combinations. Okay? So let's start off by doing binomials times trinomials and then trinomials times trinomials. Okay, a binomial times a trinomial, the question would look something like this. A binomial times a trinomial. Now sometimes you might have the trinomial first and the binomial second. That doesn't matter. This process of distribution will work either way, but I like to put the binomial in front of the trinomial, but that's just my preference. You don't have to. So the main thing is we have to multiply every term by every term. We did the same thing when we multiplied two binomials and called it FOIL. We multiplied everything by everything. We could also call that FOIL process a double distribution because we did the distributing once and then twice. It also works here, okay? So let's try it. We're going to multiply everything by everything, starting with this first term. We're going to multiply the first terms. X times x squared is x cubed. X times positive 3x is positive 3x squared. And then x times negative 2 is negative 2x's. Okay? I should have moved that over a little bit, but anyways. Then we're going to go over here, plus 5x squared. No frills, no thrills, no editing for me, so I'm going to just start that again. I'm going to just move it over and give myself some room. X cubed was my first one, plus 3x squared, minus 2x's. And I just finished going 5 times x squared is positive 5x squared. And then I have 5 times positive 3x is positive 15x's. And then 5 times negative 2 is negative 10. Okay. Now, like the other type, we'll see that there's some like terms in here that we have to combine. So my first set is x squared. There they are, here. And I also have some x's. Let's start at the beginning. We have x cubed, no more x cubed, so I have x cubed. I have 3x squared and 5x squared is positive 8x squared. And now I have negative 2x's and positive 15x's is positive 13x's. And minus 10, or negative 10, that's the only constant in there, so I still have this. So you see I ended up with a quadrinomial, or a four-termed expression. Okay, by the way, if there was ever a situation, and this goes with two binomials as well, if there's some other term in here that was different than all these ones, let's say that I threw in a y term or something like that, then quite likely there's not going to be anything simplifiable here. It could end up just staying like this. And even with the two binomials, it could end up staying as four terms, not simplifiable to a trinomial. Okay, so that's it for binomials times trinomials. Just remember this everything multiplies by everything. I forgot to put that for this one. Okay. I'm going to trinomial times a trinomial. I better make sure I give myself enough room this time. It might look like this. 2x squared plus 3x minus 5 times x squared minus 9x plus 2. Okay, so this would be, again, illustratable with a rectangle. I couldn't use my algebra tiles because it's not possible to do the dimensions with something squared, but basically one dimension would be one polynomial and the other is the other polynomial, and I'm looking for the product or the area. Okay. again, I have to multiply everything by everything. So this is going to be like a triple distribution because I have 3 terms here. So 2x squared times x, 2x squared times x squared is 2x to the 4. 2x squared times negative 9x is negative 18x to the 3. Hopefully this is, you can read this, it's going to be pretty small. I'm going to move us in just a bit. Okay, now I'm going to go 2x squared times positive 2 is positive 4x squared. Now I'm going to go into here. 3x times x squared is positive 3x cubed. 3x times negative 9x is negative 27x squared. And 3x times positive 2 is positive 6x. Oh boy, I'm going to be scrunching again. I'm going to change to a different color just because it's going to get confusing here. Negative 5 times x squared is negative 5x squared. Negative 5 times negative 9x is positive 45x. And finally, negative 5 times positive 2 is negative 10. Now that's some bad spatial awareness on my part. Okay, so now I'm going to simplify all this. Let's start. We're having a color here. So, do I have any other terms that are x to the 4? No. So I have 2x to the 4s. Do I have any other x cubed terms? Yes. I have negative 18x cubed and positive 3x cubed for a total of negative 15x cubes. Okay, I'm going to circle my x squared terms. Here I have 4x squareds, and I have negative 27x squared, which would be negative 23x squareds. And I'm going to box my x terms. Let's see, do I have any x terms? Yep. 6 x's, and whoops-a-daisy, I had 3x squared terms. Let's back up here a little bit. Sorry about that. No frills, no thrills. Let's try that again. I had 4x squareds and negative 27x squareds is negative 23x squareds. But another negative 5x squareds brings me from negative 23x squareds back up to negative 28x squareds. There, that's better. Okay, now I'm going to go into my x's. I have 6 x's and 45 x's for a total of 51 x's. And then I have my only constant, minus 10 at the end. And that's it. Okay? It's really nice that I happen to have it in descending degree. I have 5 unlike terms there, not simplifiable. That's it. I think I would have been better off turning it the other way where I had more length. Okay, next we have cubing a binomial. By the way, if I had something cubed like 3 cubed, that could be illustrated using a cube instead of a square, or if there are different dimensions, a rectangle. So this could be looking something like this. There's a square. Kind of like a Rubik's Cube. Every dimension, 3 by 3 by 3. How many cubes would there be? 27. 3 cubed is 3 times 3 times 3, which is 27. So when we have cubing a binomial, the only difference here is we have a cube. Each dimension is this base of x plus 5. So it's x plus 5 by x plus 5 by x plus 5. And we're going to look for the volume of that. Okay, so how would I do that? Well, whoa! No frills, no thrills, remember. Okay, anyway, I could go x plus 5 times x plus 5 times x plus 5, and then go left to right. My preference is I'm just going to go x plus 5 times x plus 5 squared, or x plus 5 squared times x plus 5. So x plus 5 times x plus 5 squared. That x plus 5 squared will give me the area of the base, or the front side, and then multiply by the depth, or the height. Remember, big B times h. So that'll work. If I do this, I have a little bit of a shortcut. X plus 5. Remember, when I square a binomial, it's this squared, which is x squared. I'll get a middle term, don't forget that. X plus 5 is 5x, and I'll have two of those, so I double it. That's positive 10x. And then 5 squared is positive 25. Okay, now I can do this, it's a binomial times a trinomial. So I'm going to go back to doing what I did a little bit ago. X times x squared is x cubed. X times 10x is positive 10x squared. X times positive 25 is positive 25x. 5 times x squared is positive 5x squared. 5 times positive 10x is positive 50x's. And 5 times positive 25 is positive 125. Okay, now when I simplify, I have x squared, cubed, 10x squareds, and 5x squareds is positive 15x squareds. Positive 25x's and positive 50x's, positive 75x's, and plus 125. Done. So that's cubing a binomial. My suggestion again is to make it a binomial times the same binomial squared. Finally, multiply squaring combinations. Well, that was kind of one of them right there, where it's something times something squared, or something times something cubed. Now, it could be a monomial like this. What we have to remember is the order of operations. We have to square this before we distribute that through. So I'm going to take care of this part first. X squared is x squared. X times 5 is 5x, double is positive 10x's. And then 5 squared is positive 25. Now I can go ahead and distribute and get my trinomial. So that'll be 3x cubes plus 30x squareds plus 75x's. Done. Okay? And there's really a limitless number of things that we could do here. We could have all sorts of stuff here where we have a binomial times, let's see, binomial times something else squared. The main thing is that you remember exponents come before multiplication. So as long as you take that into account, you shouldn't have any more difficulties with that. We have all the steps that we need to do pretty much anything as far as problem solving. Now the only thing left in that particular unit is to solving problems or diagrams. So we're going to have all sorts of things where we will be given some different dimensions and we have to find out areas or volumes or whatever. Remember, we can find areas of composite shapes like this by finding the area of this piece and adding this piece, or we could even find the area of the whole thing and subtracting what's not there. So there's different strategies that we can use. But the math is the stuff that we've been doing the last few lessons, and we just have to apply it now to solving problems. So that's it for the Polynomials chapter. The next part, we will be doing the reverse of everything we learned in this chapter, and that's called factoring. Okay, bye for now.